Right. Okay. So, I might go grab a little bit more. Right. Okay. So, Fable is too late back there. Is something you wish to share with class? Yeah. Fable is essentially just at its most basic, is a transpiler from F# into JavaScript that is part of the Fable toolchain, and it's actually got quite a big ecosystem around it now. So it's got various plugins and libraries and stuff. So it's actually quite feature rich now. So what I'm going to do is I'm going to use the example Fable application and show how you basically create an application to start with. We'll fire it up, see how it kind of runs in kind of developer mode, and then we'll have a look and see what's actually going on under the covers, and maybe fiddle with a few bits and see how we can change the behaviour in place. So, if I, first of all, right, so if I create a new project to start with, so who's familiar with .NET's Core? Okay, so it's all integrated in really quite nicely. So if I'm going to create a new project to start with, first off, I want to see what I've got. So if I just create this, so you can see here, we've got a standard FS approach, and we've also got a package.json, but we've also got blocks and Yarn and Webpack. So you can see we've got two different worlds colliding here. So if I do the first one, so what this is doing is it's installing the node side of things. So that's things like your SAS compilers. I need network, don't I? You're supposed to cache it all. If I just type in this that's better. So this is F# increase the difficulty. Yeah. Oh, I don't know if I've typed it in right yet. Right, okay, so I'll have another go with Yarn. So this is just doing the normal Yarn stuff with pictures and waiting. Okay, that's nice and quick. And then we want to get the .NET side of things in. So in the future, I'm going to provide a modular functions to deal with my top line data type, which actually hopefully this should be almost fast. We'll see. I can go in and redefine this part of the chapter as a modular functions. So far, I think Yarn is winning. Well, Yarn tells you where. Without ever breaking my implementation, so there's a real benefit. So this is kind of really simple I think that's probably about a dead heat. Okay, so again, because it's all quite nicely integrated, or before we do that, let's bring up some code.
And I always call them the same thing because that makes sense. Obviously, if I do this in F#4, it complains because it says, hang on a minute, you've already got a cell. You can't actually use this. So you have to put this piece of.
Right, so to run this, it's as simple as that. So what this is doing is it's starting up Webpack.
Yeah.
So does anyone know about Webpack? Can anyone explain it to me?
It's a bundle.
Yeah. Okay. So what it seems to be doing is hacking this, but also
so this is now where we get to do stuff with ourselves.
it's watching for F# changes. So it's actually handled the transpiling of F# into JavaScript. It's also off the top of the screen now, but it's also handling the other artifacts like SAS. So if I was to fire this up in the browser,
I don't have to type these things because it's going to refer it. And all I'm going to do is take my cells and match it with if it's alive.
so here we have a pure F# application rendered in your browser with 100% JavaScript, which I think is quite cool. And that But one of the other quite cool things is, if I can work out how to get into developer tools, is so
because there's the third case, which is for anything else, just leave it the same. So this is now my business logic. It's the entire
in here. So here we have in the browser. This doesn't look very JavaScripty. Yeah. Yeah, it's nothing that magic, but I think it does look really nice. But the good thing about this is you can add breakpoints and you can trace through code on the browser in F# pretty seamlessly. The other good thing, so that's all well and good. So if I'm in the code here, so say for example, this is my SAS file. If I make a change here, for example, I want to make that, if I save this, so you can change the code and it will be reflected in the browser in situ. That was in the SAS, but say for example, I go into a view and change that. Again. So again, that's leveraging node functionality that's quite familiar to front-end devs, but it's quite nice to be able to see it work in this context. So, who would like to see the kind of code behind? Before we do that, are there any questions about the kind of setup and the infrastructure? Funnily enough, the framework that does this is called Elmish. So yeah, and in fact, if you go to the Elmish site, a lot of this just links to the Elm site.
So, sorry, what part of this does Elmish do?
I'll see what function
I will show you. So, okay. So the kind of way into this, if you like, is the app. So we import the SaaS. That does some magic. I'm not quite sure how it works, but it's Webpack goodness. These are the views. So that's a kind of React component,
Does that make sense?
as is this,
Okay. All right.
and this is your root.
This is now.
So these are React views with a little bit of Elmish magic on top. So how we start, this is the bit that kind of kicks it all off. So essentially, this program is an Elmish library function that's very much like Elm. And this make program basically tells you how to set up. So init is the initial view, and update is the is the view that's rendered as you feed update commands into your dispatcher, which I'll get onto in a minute. The navigatable is an extension to let you do
So again,
single page app routing.
I'm just selecting the whole thing.
But interestingly, you can use F# fragments around it,
So
and then
just
run just kicks the whole thing off.
So
So,
I'm going to say a function.
I don't know.
Don't care about the X and Y. It's, let's say,
It might just be to a comment or to know this to know or region.
sorry, it is weird.
Don't know.
Well, I get back to 10 by 10 so I want to be a bit more.
So, if we look at the init first,
I'm going to say if X is E,
so
otherwise,
the
to a dead cell.
the results from your init and your update is a tuple which contains the model
So that works fine.
and a series of commands. Those commands aren't actioned immediately, they are fed into a dispatcher which will then be run through asynchronously. So that kind of gives you, I guess it's like a kind of a reactive kind of way of doing things. And if we look at this init here, essentially all it's doing is calling the inits of the subcomponents. So if we look here, we've got a counter and a home and a URL update. And if we look over here, here's our home and here's our counter. We've got an about as well, which we can have a quick look at. So yeah, so essentially we create this model and then we give it a command. A command can be many things, including a collection of other commands. Probably easiest to drop down to the source code. So
this parameter here, which is actually going to be a 2D array, is for me going, it's just a really nice way of so what am I going to do? I'm going to take my
So, as you can see, there's not a great deal of source code to this. So, having a poke around in the actual source itself is quite a good idea, I think.
which takes a
So,
B to C, an array of B's and returns an array of C.
so the kind of Elm side of things is very much
And
you feed it messages or commands, and it's kind of asynchronous in that it will have a dispatcher which will then use to process those commands, which may spawn other commands and so on and so forth. If we have a look at the command here, this module defines the types of command that we have. Though I guess if you wanted to, you could also define other ones. So we've got nothing, which is good. We can also create commands that are just from messages, or we can batch them together. Map seems to be the one that's used the most. Map is also the one that I can't quite get my head round, but it does seem to be very important. I prepared this immaculately. Interestingly as well, you can also use the async. So if you're using the F# async computation expression, you can put that expression into this command, and it will run that as though it's an asynchronous piece of code, and when it gets to the end, it will dump that into your output. So again, you can make your code very responsive and very asynchronous in a very kind of lightweight way. There's also, if you're using a third-party JavaScript library which is using promises, again you can just use it like this and just drop a promise in there. So you can write idiomatic F# code, but it has all the hooks that you need to plug in third-party JavaScript libraries. I think it also puts in polyfills as well, so it gives you access to fetch and that kind of stuff. Any questions so far?
How do you go about this? Well, kind of like, it sort of feels like if you were trying to write code that was entropic heavily with browser, DOM, libraries and stuff, then you would end up having to use a lot of exception styles, a lot of exceptions, a lot of managing errors from JavaScript libraries in the outside world that is maybe idiomatic to
I guess it's the same with using anything like that. So if you're using F#, you're going to have server side, you're going to have the same problem with C# libraries. Same with Scala and Java, I guess, as well. There is a kind of, there is a chasm and you can bridge it, but the bridge might not always be very nice. I guess if you were doing that, you'd probably hide it behind some kind of backup.
It's kind of what I was thinking, having a look at this. It looks like, I'm not sure what the code's doing, but it seems to be a lot of exception, like wrapping things. So is that sort of stuff speaking to the outside world or speaking to the DOM, or is it?
I don't think it's speaking to the DOM per se, because in the kind of Fable world, and even to an extent the Elmish world, it leaves the DOM stuff to other libraries, and it just does either transpiling or, in this case, the React kind of thing. So the actual React plugin itself, again, is a separate third party. Well, not it's part of the suite, but it's not core to this. So Fable itself is made up of lots of small bits that just do one thing. Right. So the standard kind of arrangement for this is you have a component of some description. You start off with a state. Actually, no. You start off with types, which is basically your model, and you have a state, which is your initial state here, and this is the update is the part that mutates mutates the state. So so it's very much kind of feeding values in and getting a new immutable model out. You can see here that we return we return a tuple of a model and commands. This is just a command null, so it doesn't actually do anything. so there's no command associated with this.
So I'm going to say.
So in our view,
Instead of using my direct access, I want to get a set.
I guess this is the interesting part, or the immediate React part. So essentially, you have a series of elements or React bits. So that is actually a function call that takes in two parameters. So this parameter is a list of HTML attributes, and this parameter is a list of HTML or React elements. So you get something that kind of looks a little bit like RX, or actually I suppose it looks a bit more like Haml. But yeah, once you set the formatting to one side, you can see how you've basically defined an HTML view here, but you've done it completely in situ, in code, and it's all strongly typed according to the F# type rules. Any questions for that? So
is that kind of template syntax that's specific to React? Like, what's kind of the distinction between React and HTML?
So these are all React components. So if we look at the definition of this, you see it's a React element. It's coming from the React namespace. When it compiles it down to JavaScript, it's compiling it down to the R dot things.
Could you use this server-side templating?
It's funny you should mention that. I did spend quite a lot of last Friday trying to do just that thing. To kind of try and do an isomorphic web app application. The problem is this, as it stands, is really focused on just generating client-side apps. So if you try and run this code as native F#.NET code, it just blows a raspberry at you and says this can only be run in JavaScript. So what I was trying was just trying to punch it to see if I could make it be a bit more forgiving. Because, in fact, let's have a look. So, if we look at the React side of things, and again, this has a really small amount of code. You can actually, just mention in passing, you can use this to create web native React apps as well, which I think is starting to gain quite a lot of traction. Does front-end want to explain React Native? Yeah. So basically, native mobile applications using F# that's been converted to JavaScript, which then pretends to be a real app. So yeah, not jumping through too many hoops. But yeah, apparently it works really well, and people are starting to do it quite well. Yeah, so this is what your actual React, I guess it's kind of like a shim, so this is the bit that kind of tells the compiler how to turn this into the React commands. But that's probably because I'm thinking of the other one. No, maybe I'm thinking of a different one entirely. Yes, I know what I'm looking for. So it's not this.
Start applying the cells to the grids. And in this case, you could see that as the grids. This is dealing with cells, but you can make this completely generic with very little work you have to take out.
There's loads of examples on their site as well, which are pretty good. Right, so
So I'm going to just create a game module, and I think I'm going to have a create random function, which takes
Here
a
we go.
size. And all that's going to do is
So we can see how basically they've taken all the kind of
number.
elements that you would use in React, and well, this is a discriminate union, so it's all nicely typed and everything. Someone's done a lot of typing. SVG as well, which might actually be quite a good thing. It might bring some sanity to doing sort of dynamic SVGs. But you can see here how we've got all of these things and they all end up with this JS native. So if you try and run any of the code that ends up on a JS native, all it does is it throws an exception saying, no, not going to. So my kind of idea was, well, I could just change that to be something a bit more amenable, but I haven't quite got there yet. One of the things that's kind of interesting is this on change here. So from this you can see that it's quite easy to, I guess this shows the bridge between the kind of HTML world and the F# world. So we've got an event which has been defined, and we can just pick those bits off. This question mark is basically a way of doing a dynamic. So even if we've strongly typed and we've dropped outside of our type system, we can still get at these values. And then put it back, and it works quite nicely in our more traditional F# forward pipe, something pipes into something, pipes into something. Any other questions so far? Is this a good point to kind of maybe take a slight pause and see what kind of comments people have on it?
Is it kind of mature, like production, mature, or is it still sort of?
It really does seem to be. In some ways, it does seem like a bit of a. It was done because it could be done. Was that such a great idea? But it does seem to be getting a fair amount of traction. It's got quite a big ecosystem. The Gitter channel for it is really chatty. There's an awful lot of conversation going on there.
I did see something on the Slack channel saying they've just gone from a single maintainer to a group. So you know, it's getting more stable, I think.
Yeah, and I think for each of in the ecosystem, all the different bits. So say like the Fable bit, the Elmish bit, and the React bit. I think they all have they're all separate projects. So a lot of those have got separate maintainers. There is actually, it's got its first conference coming up in September. So it's got a conference, it must have hit big time, which is in Bordeaux. So I'm going to see if I can persuade my new bosses.
So if you need React components at the front end to talk to each other, like say using a store, how would that work?
I don't know,
Okay.
but I don't know enough about React. But there are quite a few React libraries that have got like a Fable shim over the top, so you can actually use them. I think the kind of React Redux, Reflux libraries, I don't think those would be applicable because it's got the Elm library, which does a similar thing but in a more kind of Haskell type way. So I think that library support would be relevant to this because you use Elmish to flow the events through, and then for that kind of store library calls and that kind of stuff, you just use idiomatic F#. But I think we'd end up with a similar kind of.
Final thing.
So,
Come back to me.
so would you think that you'd use Suave on the back end and then the F shell all the way down?
There is actually one of the examples is it's an isomorphic Suave Fable demo. It's not true isomorphic in that you can render server side and then just display it. What the hell is going on with this?
That's happening early on.
Yeah.
Well, I'll just come and stand behind you.
I'll just hold it up and you can squint. I might just unplug it for a minute. Yeah, so what were we talking about? I've forgotten.
Suave.
Suave, yeah, so there's a really good demo, which is Suave and Fable Elmish React. It's not isomorphic in that it renders server side and then just displays that as static content, but it does show you how to do shared models and shared kind of code with the actual view models, just kind of in their own bit, but sharing the majority of the business logic and the details, that kind of stuff. It also shows you how to combine the testing as well. So running standard unit tests on the server side, and one of the other plugins is a Fable converter that will convert NUnit tests into Jasmine. So you can also write standard NUnit tests and then run them on the client side as Jasmine tests, which is quite neat. And all of that's kind of bundled up in the example, but it's quite cool.
When it comes to dealing with other JavaScript libraries, is it kind of like TypeScript where you can define a shim, or like someone needs to write like an interface that gives you strongly typed access to that library before you can use it?
But that was basically what we wanted to show.
Sure.
Some stuff in there.
I know you can use the TypeScript way of doing it. So I think there's a TypeScript provider where you basically have a type provider. Does everyone know what type providers are? So I think you have a type provider to the TypeScript interface file, and it will give you the kind of goodness from that. I think also the interop, it might be shim, but I've got a feeling as well that it will also take the function information from the ES module format. I think it does something with. I'm not sure about that. You need to have a look, but I think there are ways and means of making the interrupt as painless as possible. The other good thing that it does as well is because it's ES6 modules all the way, makes tree shaking really easy. So I think the F# modules map one-to-one with the ES6 modules, and the imports and the exports there are all quite explicit. So when Webpack comes to tree shake it, it's quite easy for it to work out what's required and what isn't. Tree shaking is where it basically walks the JavaScript AST or the compiled code and works out what code is used and what code isn't, and the code that isn't used, it throws it away when it bundles it. So you can have much smaller JavaScript files.
What we actually apply the JSX syntax? I don't suppose it's something similar.
No.
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 Suppose they've already got FSX.
Yeah. Well, you've got that way of defining it basically using the language constructs to define arrays. So you basically just define it in that way, which I think you end up in the same place, and it looks similar. It just doesn't look like XML, which isn't necessarily bad though.
It's almost
And it's all strong types as well. Anything else?
Nice because you instantly then have to think about.
Okay, it sounds like they're wrapping up over there, so I will wrap up here.